Today we're learning about four-sided polygons. Let's refresh ourselves on what a polygon is. So a polygon is a figure with straight edges or sides. These sides can only intersect at vertices. A polygon is closed and coplanar. Think of your paper as a plane, P-L-A-N-E, okay? So a plane is a flat surface that can extend in all directions forever and ever. So when a polygon is coplanar, that means that it has to be on a flat surface, meaning that it would be a two-dimensional shape. All right, let's go through some examples that would be polygons and some that would not be considered polygons. A triangle would be a polygon because it has straight edges and sides. The sides are only touching at vertices. It is closed, meaning that all the sides meet together, and it is coplanar. We could have a pentagon. That would be a polygon, okay? It's got straight edges and sides. The sides are only intersecting at the vertices, and then it is also closed and coplanar. In this specific example, we call this a convex polygon. We could also have another pentagon that might look like this. And this one is still closed, it's still coplanar. The sides are only intersecting at the vertices, and it has straight edges and sides. But more specifically, this one is called a concave polygon. Some examples of things that would not be polygons, some shapes. If we had a semicircle, that would not be a polygon because although there is one side that is straight, one of the pieces or edges is curved, so not a polygon. Another shape that would not be considered a polygon is this shape because the two lines here and here are crossing each other. They are not just intersecting at a vertex. Also, a shape that looks like this would not be a polygon because it has a curved side, and something that looks like this would not be a polygon because it is not closed. Let's talk about diagonals of polygons. So diagonals are the segments that connect two non-consecutive sides or vertices of the polygon. Segments that connect two non-consecutive vertices of the polygon. So for example, let's draw a polygon. Let's start with a shape that resembles a rectangle. A diagonal is going to connect two opposite vertices. So let's say we look at that top right vertex. The one that is non-consecutive would be the one that's across from it. And so if we drew a line from one vertex to the other, we would call that a diagonal. There could also be a diagonal drawn between the other two vertices. Let's draw one more example. Let's do a pentagon. So we're going to connect two non-consecutive vertices. So for example, I could connect this one and then another one that is not next to it. So maybe I connect it to this one. If I draw a line that goes between those two vertices, we call that a diagonal. I could also draw a diagonal in a few other places. I could connect this vertex with another one that is not directly next to it, perhaps this one. If I draw a line between those two vertices, we would call that a diagonal. Again, I can do that through quite a few different vertices. I can do that with this one and one that's not next to it, perhaps that one again. And if I draw a line between those, it would create a diagonal. So there can be more than one diagonal in a shape. Specifically in this chapter, chapter 5, we're going to focus on quadrilateral shapes. So a quadrilateral is defined as a four-sided polygon. So we're going to go through all of the different types of quadrilaterals we can have. But let's write our main definition of what a quadrilateral actually is. It is a four-sided polygon. An example of this shape would just be a four-sided closed figure with all straight edges. All right. Next, we have a parallelogram. A parallelogram is a type of quadrilateral. So it is a quadrilateral in which both pairs of opposite sides are parallel. So when we think of a parallelogram, generally we think of something that will look like this, where we have two pairs of opposite sides that are parallel. So I would know that the two bases, top and bottom, are parallel, and then the other two sides, the left and right side in my diagram, are parallel as well. Those arrows that I have marked in the diagram, that's showing me which pairs are parallel to each other. Next, we have a rectangle. A rectangle belongs to the parallelogram family. So a rectangle is a parallelogram with a few other properties. It's a parallelogram in which at least one angle is a right angle. So when I draw my diagram, I'll start with what I know to be a rectangle. Since it's a parallelogram, it is going to have the same properties as what we had before. So we'll have two pairs of sides that are parallel. In a rectangle, I know that there is at least one right angle, so I'm going to add a right angle into my diagram. And I also know that the opposite sides are going to be congruent. A rhombus also belongs to the parallelogram family. So a rhombus is part of the parallelograms. It's a parallelogram in which at least two consecutive sides are congruent. So when I draw my rhombus, I'm going to make it similar to the parallelogram, but I'm going to have sides that are congruent. So my rhombus will look like this. Since it's a parallelogram, Both pairs of opposite sides are parallel, so I'll mark that in my diagram. And at least 2 consecutive sides are congruent. So here, I'm going to show that the sides are all congruent. Next, we have a square. A square is still part of the parallelogram family. So a square is a parallelogram that is both a rectangle and a rhombus. So when I draw my square, the opposite sides are parallel. The sides are all congruent to each other, and there is at least one right angle. So our main parallelograms, we have the parallelograms, rectangle, rhombus, and square. Those are all part of the same family. All 4 of those are also considered quadrilaterals. Now we're going to look at another shape. This is called a kite. So a kite is going to be part of just the quadrilateral family. The kite is not a parallelogram. So a kite is a quadrilateral in which 2 disjoint pairs, which I'll explain in a minute, in which 2 disjoint pairs of consecutive sides are congruent. At the bottom of this page, it tells you what disjoint means. So disjoint means that the 2 pairs of sides are totally separate. One side cannot be part of both pairs. So I'm going to further explain it in this diagram. So let's go ahead and draw a kite. So I'm going to draw 2 shorter sides, 2 longer sides. What it means by disjoint pairs of consecutive sides is that if I'm saying the smaller side is congruent to the smaller side, the smaller and the longer cannot be congruent. So only one pair of sides that's next to each other will be congruent, and then another pair of sides that's next to each other will be congruent. That's what 2 disjoint pairs. I have 2 separate pairs of sides that are congruent, and those 2 sides touch each other and meet at a vertex. All right, we're going to move to another family. So far we have quadrilaterals, that's our big family. Then we have all of the parallelograms, the rectangle, rhombus, and square. They're one family. The kite is its own family. And then we have trapezoids. So the last section here, we're going to talk about what a trapezoid is. So let me pick a different color. All right. A trapezoid is a quadrilateral with exactly one pair of parallel sides. We call those parallel sides the bases. So we often refer to one as the upper base and the lower base. So let's go ahead and draw our diagram. So I'm going to draw 2 bases that are parallel, and then I will connect those with two other sides to make a quadrilateral. So we only have one pair of parallel sides. All right. An isosceles trapezoid is part of the trapezoid family. So an isosceles trapezoid is a trapezoid in which the legs, those are the non-parallel sides, are congruent. So a trapezoid in which the legs are congruent. So when I draw an isosceles trapezoid, I'm going to start with my bases that are parallel to each other. And then the sides joining those bases, we call them the legs, and those are congruent in an isosceles trapezoid. Now, with all of our shapes, our quadrilaterals, there are a lot more properties of each one. So I gave you the basic definition of each example here. Now, when we go to the next page of our notes, this is kind of laying out how the families work together. It also provides you with additional properties of each shape. So at the top, we have our quadrilateral family. That means that all of the shapes listed below, just like a family tree, are related to that top section. So all of these listed below are quadrilaterals. Now, in those quadrilateral families, we have a kite. Okay, so a kite was kind of its own little family off to the side. That was where we had the two pairs of disjoint sides. Additionally, in a kite, the diagonals are perpendicular. One pair of opposite angles would be congruent, and there are no parallel sides. Next, we had the parallelogram family. And in the parallelogram family, we defined it as a four-sided figure that had two pairs of parallel sides. In addition to those opposite sides being parallel, the opposite sides are congruent as well. The opposite angles are congruent, and then consecutive angles are supplementary. That means consecutive angles, this angle and this angle, would add to 180. The diagonals will also bisect each other. So when we draw from one opposite vertex to the other, if I were to draw two in there, for example, here and here, the opposite, or they would bisect each other. Part of that parallelogram family were rhombus and a rectangle. Now, a rhombus and a rectangle are ending up to be related in the end, which I will show you in a second, but a parallelogram can either be a rhombus or it could be a rectangle. A rhombus had four congruent sides. The diagonals are also perpendicular in a rhombus. So when I draw my diagonals, they would be perpendicular. And the diagonals bisect opposite angles. So this angle would split into two congruent parts. Now, everything that was also true about a parallelogram is true in a rhombus. So a rhombus still has two pairs of parallel sides. Its opposite sides are congruent. Its opposite sides are parallel. The opposite angles are congruent. It has consecutive angles that are supplementary, and the diagonals also bisect each other. Now, a rectangle is a little different. We defined it as having at least one right angle. In addition to everything that was true about parallelograms, opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles are supplementary, and the diagonals bisect each other. Additionally, the diagonals are congruent to each other. So these two diagonals, they would be congruent. Now, if I put together a rhombus and a rectangle, I get a square. So a square has all the properties of everything above it. It has all the properties of a rhombus, it has all the properties of a rectangle, and it has all the properties of a parallelogram. So when I put all that together, it also will tell me that there's 4 right angles, 4 congruent sides, 2 pairs of parallel sides, opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, the diagonals are bisecting each other and congruent, the diagonals are also perpendicular, and the diagonals bisect opposite angles. So there are a lot more properties of each shape as you continue down into this family. Then we had our trapezoid family. So our trapezoid family has exactly 1 pair of parallel sides. It is also a quadrilateral, so it has 4 sides. Part of that trapezoid family were those isosceles trapezoids. And now we get to add a little bit more of our properties. So in an isosceles trapezoid, it's a trapezoid, which meant that 1 pair of sides is parallel, and it has congruent legs. Additionally, the base angles are congruent, so these 2 lower base angles are congruent, and the 2 upper base angles are congruent. And if we were to draw the diagonals in, they would both be congruent to each other. Now, this chart is helpful in doing true-false questions and always, sometimes, never questions. It really helps us visualize everything. So if we were to ask, is a parallelogram a quadrilateral, always, sometimes, or never, I would know that a parallelogram is always part of that quadrilateral family. A rectangle is always part of the parallelogram family and part of the quadrilateral family. A rhombus is always part of the parallelogram family and the quadrilateral family. And then a square is always part of a rhombus, a rectangle, a parallelogram, and a quadrilateral. So as I'm moving up in this chart, I'm saying the word always. A kite is always a quadrilateral. A parallelogram is always a quadrilateral. An isosceles trapezoid is always a quadrilateral. Okay? Then, as I move the opposite way, if I'm moving down, well, a quadrilateral can be this, this, or this. It could be any of those things. So as I move down, I would be saying the word sometimes. A quadrilateral is sometimes a parallelogram, but it's sometimes a trapezoid, and it's sometimes a kite. A parallelogram can be a rhombus and a rectangle. So a parallelogram is sometimes a rectangle, sometimes it's a rhombus, sometimes it's a square. Sometimes it's just a parallelogram. If I tried to move left and right, a trapezoid and a parallelogram, the only way that they're related is that they both have 4 sides. But a trapezoid and a parallelogram are not part of the same family. So a trapezoid is never a parallelogram. An isosceles trapezoid is never a rectangle. An isosceles trapezoid is never a kite. So as I'm moving left or right, I would use the word never. The only special scenario is with a kite and a rhombus. Okay, so a kite can sometimes be referred to as a rhombus, and a rhombus can be referred to as a kite. So this is that special scenario right here, that it's a sometimes. We say that a kite doesn't have any pairs of parallel sides. So it does, though, have pairs of consecutive congruent sides, and so does a rhombus. Also, something that would be the same is that the diagonals are both perpendicular. So we can use that one. It's the only special scenario, and we can use the word sometimes between a kite and a rhombus.